So the first thing that I see is it's obviously we have to use quotient rule as well as I'm probably gonna say chain rule as well. Um, so the first thing is let's just go ahead and do the derivative of the top through product rule and quotient rule, or product rule and chain rule.
Okay.
That would be f prime g plus g prime f. So that's e to the 5x times x plus 1 squared.
Okay, yeah. E to the 5x times what?
X plus 1 squared.
Okay.
Plus e
Are you
to the
taking the
5x.
derivative of anything?
Yeah, of e to the 5x.
What's the derivative of that?
Just itself, right?
Okay, but that's for e to the x. What's the difference between e to the x and e to the 5x?
You're would it be 5e to the x?
5e to the x. This is a function.
Okay, got it. Got it.
Yeah, you have to use chain rule here. Okay.
Plus e to the 5x times 2x plus 1. So 2 times x plus 1.
Okay, yep.
And now we can probably just simplify that second term to 2x plus 2. Or is that, nah, I guess we can just keep it like that.
Yeah, let's just keep it for now.
So that's a derivative of the first of the numerator. So the derivative of the square root of x times cosine cubed x. Again, we have to use product rule there.
Okay.
So it's the derivative of the square root of x. So it's x to the 1/2, right?
Yeah.
So that'd be 1/2 x to the negative 1/2 times cosine cubed x.
Okay, yep.
Plus the square root of x times, would that be 3 cosine squared x?
Okay.
So that's the denominator of the
Anything
the
else?
derivative of the denominator. Are we just talking about the derivative of the denominator?
Yeah, how's this function set up? What kind of function is it?
Oh, it's a chain rule, right? We have to use chain rule there.
Composite function.
Yeah.
Right, because there's two things happening to the x, right? The cubed and the cosine.
Mm-hmm.
And the cosine's happening first, so it's in the inside, cube's on the outside.
So then we'd have to multiply that by the derivative of x, which would just be
would you
1.
take the derivative of, what would you take the derivative so far of?
Oh, just the outside.
Which derivative would you apply?
Power rule?
Power rule, right? Which applies to which part of the function? Or which function?
The x cubed?
The cubed part, right.
Right.
What else do you have to do?
Take the derivative of cosine?
Yeah, which is what?
Negative sine?
Yeah, negative sine.
So it'd be negative sine cubed x?
Well,
or
so
just negative sine x?
What's the inside function?
Yeah, it is the cubed x. So it is just negative sine x.
Yeah, because technically this is the same as cosine x cubed, like that. That's why the inside is just the cosine x.
Okay, got it. So now that's the derivative of the denominator. Now we just have to put it all together, sort of ish. Does that make sense? So using quotient rule.
Okay, yeah.
The denominator times the derivative of the numerator. So square root of x times cosine cubed x. Times the derivative of the numerator, which is the 5e to the 5x, right? Or is it 5 to the x? No, 5 to the 5x. Wait, could you explain why that's 5e to the 5x instead of 5e to the x?
Yeah, because remember, you can think about it as the outside derivative is e to the something, right? And the inside, sorry, the outside function is e to the something, inside function is 5x. So in this case, it breaks down to f of x is equal to e to the x, g of x is equal to 5x, right?
Okay,
And
right,
then
that
the
makes
composite
sense.
function is f of g of x, which is equal to e to the 5x, right? So then remember, do you remember the formula for chain rule?
Yeah, f prime of g times g prime of x.
Yeah, exactly. F of g equal to f prime of g times g prime. Okay, so what's f prime of g in this case?
It would be e to the 5x.
Yeah, f prime is e to the x, but we have to plug in g for x, which is 5x. So that's why it's e to the 5x. And then what's g
And multiplied
prime?
by is just 5.
Yeah.
Got it. Okay, that makes sense. So then going back to our derivative, it's 5e to the 5x times x plus 1 squared plus e to the 5x times 2 x plus 1.
Yeah. Okay. 2. Okay. Yeah.
Minus, so I guess all that in parentheses. Minus e to the 5x times x plus 1 squared. This might be a little long.
Yeah. Minus the 5x x plus 1. Okay.
Times 1/2 x to the negative 1/2 cosine cubed x plus square root of x times 3 cosine squared of x times negative sine x.
Okay. Yeah. Your teacher doesn't really care about the order, right? Or simplifying these too much.
No, this would be
Okay.
fine.
Okay.
And then
minus
all of that, I guess, over negative or the square root of x times cosine cubed x squared.
square root of x. Yeah. Okay. Yeah. Would this be good enough then? You think?
Yeah, that would be.
Okay.
He says that once we get to like the derivative, that simplifying it just leads to more mistakes. So this would be completely fine.
And just maybe another. Yeah. I guess that's kind of what we did. So I was just kind of labeling this. Okay. That's fine. F prime, which is the numerator derivative. This is g prime. Then you can label this as f. This is g. And then you can just then easily see kind of easier how everything fits. And always try to look for chain rule, right? You just keep on going until you reach x, when the derivative of x is just 1. So that means you've went all the way.
Makes sense.
Okay. Looks good. So yeah, this is fg. Okay.